In 2015, an aerospace engineer quit his job building jet turbines to out-engineer Dyson. His mission? Build what even the world's best couldn't. His name was Hao, and what followed was one of the most audacious challenges to a global brand icon in recent memory. This is the story of how a man who spent his days calculating airflow for rockets decided to take on the world's most prestigious vacuum maker and somehow started winning. Hao wasn't your typical entrepreneur. He studied computational fluid mechanics at Tsinghua University, one of China's elite institutions, where he focused on airflow control for high-speed aircraft. This wasn't abstract theory. The math was exact. A single mistake could cause catastrophic failure. He was doing practical work tied to rocket propulsion, where precision wasn't just preferred, it was mandatory. After graduation, he started Sky Workshop, a small hackerspace that quickly drew interest from Boeing, which saw enough potential to invest. The appeal was simple. They were solving problems others struggled with, using the same software that models rocket engines to design better motors with clear, testable results. Those early aerospace projects taught him something crucial. In aerospace, a millimeter off could crash a rocket. In vacuums, it could waste 20% of suction. When systems run under extreme conditions, every component must be precise. And then one day, he began to see something others had missed. The parallels between aircraft turbines and vacuum motors. Both move large volumes of air. Both rely on high-speed rotation without failure. Both depend on precise airflow control. The difference? Turbines follow aerospace standards while household motors use lower specs. Many engineers dismissed bringing aerospace precision to home appliances. They said costs would be too high and manufacturing too complex. They assumed customers wouldn't pay for it. He disagreed. That disagreement would change everything. Think about it. Vacuum motors often run at 20 to 30,000 RPM with loose tolerances. Aircraft turbines run at far higher speeds with stable performance. The materials exist to build better motors. The software exists to optimize airflow. The factories exist to make precise parts. The goal crystallized. Build a motor to aerospace standards at a consumer price. Use the same computational methods that keep fighter jets stable to make airflow better in your living room. Apply tight tolerances. Deliver performance that makes current vacuum motors look outdated. But vision alone wasn't enough. Hao still had to prove the market leader's approach had basic flaws. By 2015, Hao was ready to make a clear claim. Dyson's motor tech could be surpassed. This wasn't hype. It was based on technical analysis. The data showed gaps others overlooked. Dyson led the premium vacuum market with its digital motors. The hyperdymium motor in the V15 Detect spun at about 125,000 RPM. The company presented this as cutting-edge and charged premium prices. Their cyclone system and bagless design had changed the market. Customers trusted the brand implicitly, but Hao saw their strategy differently. Dyson built strong products through design-first choices and iconic motors. He aimed to apply aerospace methods in a more systematic way. Where Dyson optimized each product individually, he wanted a unified approach. His principle was simple. Being first should be a habit. He didn't want to race on the same track. He wanted to jump ahead entirely. This led to Dreame's plan for a power heart. One advanced motor platform for many products. Handheld vacuums, uprights, robots. Rather than developing separate motors for each device, he focused on 3 aerospace-derived technologies. Magnetic levitation bearings to reduce friction and allow higher speeds. Computational fluid dynamics to refine airflow throughout the system. Advanced composite materials to handle extreme rotation while staying light. These methods were already used in aircraft engines, turbines, and rockets. The task was adapting them for mass production at consumer cost. Prototypes showed the brutal gap between theory and practice. The team reached 150,000 RPM using these methods, but costs were astronomical. Maglev bearings required tight precision. High-performance materials raised unit costs significantly. But that was just the beginning. Hao needed motors that met aerospace performance and could be built at scale. The goal was a 200,000 RPM motor that outperformed Dyson while staying cost-effective. Speed wasn't the only metric. Higher RPM could bring more airflow, stronger suction, better cleaning. Dreame's answer was a core strategy, one technology across many scenarios. Spreading the R&D over multiple products made the economics work while keeping high performance. To reach global scale, they needed strong partners. And that's where the real challenge began. By late 2017, Ahau faced a choice that would define everything. The team had aerospace-grade motor tech, but scaling prototypes to mass production needed resources they lacked. Precision motors required advanced production lines, strict quality control, and deep supplier ties. Building this alone would drain cash while rivals moved ahead. Joining Xiaomi's ecological chain offered instant access to manufacturing and supply. Xiaomi linked hundreds of partners that shared factories, engineering know-how, and distribution. For Dreame, this meant the ability to produce at scale with stable quality. But here's the tension. Joining Xiaomi meant survival, but also surrender. Would Dreame stay a hidden supplier or become a rival giant? Xiaomi had already built what Dreame needed: long-term component suppliers, proven quality control systems, testing labs, and global logistics. The benefits went beyond factories. Xiaomi's channels put products in front of customers quickly. Their marketing helped new launches gain traction. Their service network handled support. How could focus on engineering while Xiaomi handled operations? During this phase, Dreame refined its motors and built production capacity without typical startup constraints. Fast feedback from experienced engineers sped up design cycles. Supplier networks enabled rapid testing of materials and components. Most importantly, Dreame proved its aerospace-inspired motors in real products. But as the tech matured, tension grew. How aimed to build an independent brand that could compete with global players. Xiaomi's model favored partners staying in defined niches under a shared umbrella. He saw uses beyond vacuums, robots, cleaning systems, and more. Staying in the ecosystem meant these would be Xiaomi products, not Dreame's. The same partnership that fueled early progress now limited long-term reach. In 2019, the choice became final: remain a supplier with secure support or pursue independence and compete head-on. How chose independence, betting that Dreame's tech could stand on its own. It worked, and the numbers proved it. From 2020 onward, growth accelerated with major funding by 2021. Dreame emerged as one of the 4 little dragons in China's cleaning sector, challenging global brands on performance and price. Independence brought freedom to compete and a true test of their technology. When Dreame Z30 launched with a 310 airwatts rating, the market took notice. Dyson's Gen 5 Detect was rated at 250 airwatts. Let that sink in, a 24% gap. How did Dreame surpass Dyson's top model? The answer was Ahau's aerospace-driven motor design reaching maturity. Airwatts measure real cleaning power by combining airflow and suction. Dyson had led for years. V15 detect at 230 airwatts. V12 detect slim at 150 airwatts. Those figures supported premium prices, but Dyson was still spinning motors at 125,000 RPM. Dreame was about to double that. By 2025, Dreame reached mass production of 200,000 RPM motors, far above anything Dyson offered. Dreame also pushed product designs forward in ways that caught competitors off guard. The L40 Ultra's robotic flex arm cleans under furniture automatically, solving a problem every homeowner knows. The Pro Leap retractable legs lift the robot over obstacles to keep cleaning, turning stopping points into minor bumps. These features solve practical problems that Dyson's premium models don't address. The blue LED dust detection system meets Dyson's laser concept and adds connectivity. Both illuminate fine dust invisible to the naked eye. Dreame's system also feeds cleaning data to the app for progress tracking and performance feedback. Dyson's solution lacks that level of integration. But perhaps most shocking of all is the pricing. The Z30 lists around $399 versus the Gen 5 Detect at $949. The L40 Ultra is $1,199, while offering features Dyson's robots don't match. This brings high performance to a broader audience. Yet brand perception remains a hurdle. Dyson has decades of trust, retail presence, warranties, and service that reassures buyers. Newer brands must earn that confidence over time. And here's what nobody talks about. As Dreame scaled, customer service issues grew like cracks in a foundation. In the US, some repairs took months. Shipping delays left buyers waiting for basic parts. Support teams struggled to resolve technical cases. These problems clashed with the company's top-tier engineering image. The fast-paced work culture that drove innovation also took a toll. Accounts described mandatory overtime, weekend work, and strict performance targets. Output was high, but burnout affected quality and retention. This is where Dreame crossed the line. Competitors accused Dreame of hiring practices that brought confidential information from previous employers. Legal disputes followed. Potential partnerships suffered. Despite this, Dreame raised more funding and expanded overseas. Observers asked whether engineering wins alone could carry long-term leadership. Dyson's position relied not only on performance, but also on consistent service and earned trust. Dreame rarely addressed the controversies, leaving critics to define the narrative. That silence suggested either legal caution or a bet that product results would outweigh operational faults. But Ahou's plan extends far beyond the vacuum market. His vision is to turn Dreame into a generalized robotics company. He describes a future where cleaning is invisible, an AI-driven system that handles routine chores without user input. Their vision guides expansion across many categories, all built on variants of the same motor platform. The scale shows in the funding. Imperium Venture, Dreame's investment arm, raised $1.54 billion to back AI and robotics startups. This is meant to build an ecosystem around computer vision, machine learning, and sensors that enable autonomous cleaning. The roadmap reflects a one-technology, multi-scenario strategy across 15 categories. Robot vacuums, hair dryers, leaf blowers, air purifiers, and large appliances share the core motor architecture first used in vacuums. At IFA 2025, Dreame showed something wild. A robot vacuum that climbs stairs, actually climbs them. The X50 Ultra reads stair geometry, lifts itself, and keeps mapping as it goes vertical. These capabilities required sensors that detect stairs, motors that lift the unit, and navigation that maintains orientation during vertical movement. The Pool Vacuum Z1 applies the same motor principles to underwater cleaning. It uses high-speed performance while submerged. The computational fluid mechanics behind Dreame's motors carries over to underwater propulsion and debris capture. How's view of the smart home centers on physical automation rather than voice control? Dreame's robots would act based on usage patterns, occupancy, and environmental data, no commands needed. But moving into electric vehicles and drones will test focus on service quality across very different fields. A company that struggled with support for vacuums now aims to build hypercars and manage complex robotic systems. That's either breathtaking ambition or dangerous overreach. Until he realized something no one else did. Hao walked away from building rockets to build vacuums. But he never stopped building like a rocket scientist. He proved that real innovation doesn't start in boardrooms. It starts with obsession. From jet turbines to living room floors, he turned precision into power and built the one company Dyson never saw coming.